Starting from this video, I will introduce the commercial applications of adsorption resins and ion exchange resins one by one. In this video, we will classify resins from different perspectives. Firstly, when classified by the monomers of the polymer backbone, resins can be divided into acrylic resins and styrene resins. Commonly used co-monomers for acrylic resins include methyl acrylate, butyl acrylate, and ethyl acrylate. Styrene resins are formed by the polymerization of styrene and divinobenzene. There are certain differences in the application ranges of acrylic and styrene resins. Acrylic resins have relatively better hydrophilicity, while styrene resins are more hydrophobic. Classified by the structure, resins can be divided into gel resins and macroporous resins. Gel resins have a homogeneous polymer gel structure. There are no capillary pores in the dry state when immersed in water and swollen. Microscopic pores with an average diameter of about 1 to 2 nanometers are formed between the micromolecular chain segments. The essence of these pores is spacing between cross-linked polymers rather than real pores, and they will change with the variation of operating conditions. Macroporous rings from the porous sponge-like skeleton by adding polygen during polymerization, generating a large number of permanent pores with a diameter of over 20 to 200 nanometers. The size and the number of the pores can be artificially controlled during the manufacturing process. The pores of macroporous resins maintain good stability even in the dry state. If classified by the adsorption principle, resins can be divided into macroporous adsorption resin and ion exchange resin. Ion exchange resin can be further divided into anion exchange resin and cation exchange resins. Among them, cation exchange resin can be divided into strong acid cation exchange resin and weak acid cation exchange resins, while anion exchange resins can be divided into strong base anion exchange resins and weak base anion exchange resins. The functional groups of strong acid cation resins are usually sulfonate groups. Those of weak acid cation resins are carboxylate groups. The functional groups of strong base resins are quaternary ammonium groups, and the functional groups on weak base resins are tertiary amine and primary amine groups. In the actual manufacturing process, resins with different properties are developed according to different application requirements, such as gel, acrylic strong base anion resins, and macroporous string weak base anion resins. In the specific preparation process, for example, even if two resins are both macroporous styrene strong base anion resins, there will still be performance differences. The reasons for these differences include differences in pore diameter, strong base, functional groups, and so on.